Assalamualaikum and hi, my name is Nur Sharfa Amni binti Sayuti. Today I'm gonna to present to you about the application of vectors in physics. So, some students frequently inquire about how people actually apply vector that they have studied in school, right? So it is necessary to comprehend on how to define the unit vector. Vector is the magnitude or amount of anything, in this example force, as well as the direction that it is pointed. A vector is represented as a line with an arrow pointing in the direction of the vector, and the length of the line denotes the vector's magnitude. Vector has numerous applications in real life as well as physics. So, in my video, in my presentation, I'm going to talk about how vectors are used in physics. Using the relationship found in physics, architects can create buildings, bridges, and also residences. Physical quantities can be represented using vectors, and vectors are extensively used in physics to express displacement, velocity, and acceleration. Vectors are arrows that represent a combination of magnitude and direction. So the magnitude is represented by the length, and the direction of the amount is the vector's pointing direction. Physical quantities with both size and direction can be analyzed as vectors because vectors are produced in this way. So, the application of vectors in physics, for example, is work and scalar products. Every day we as a human does work in our daily life, right? So as we will see, work is a scalar quantity that allows us to calculate the change in object speed that caused by a force applied over a specific displacement. The displacement and the force are both vectors value. A force has a magnitude and is exerted in a particular direction. So the work that is symbol as W performed by a force that is symbol as F across a distance that symbol has D is defined as W equal to F multiplied by D. So this work is related to the change in speed of the item as it moves along the displacement vector, which is D. According to the work energy theorem, the item has the same speed at the beginning and the end of the displacement if the work is zero. So, the object moves quicker near the end of the displacement if the work is positive and slower if the work is negative. So, as we'll see in the figure that's shown in the screen, only the horizontal component of the force it would seem would contribute to changing the speed of the object as it goes down the horizontal trajectory described by the vector G. So, the vertical component of the force has no effect on changing the object's speed. As a result, the work should only be determined by the force component that is parallel to the displacement vector. We can express this as an equation using the scalar product. The scalar product is calculated as follows. So, in the previous section, we defined F cos as the component of F that is parallel to D. As we see at the screen shows. So as a result, the scalar product selects the component of F that is parallel to D, which is exactly what we need for work to make sense. So after we have looked at the application of physics in vector, which is in work and scalar, let us see the problem solving and calculation for works. So as we read the question, a constant force F is the 20 Newton pulls a block 2 meter along a horizontal surface. So we have to determine the amount of work that was done on the block by force F. So the figure on the screen shows the diagram of the block. So we look at the formula. F multiplied by D is equal to the answer. So the F is equal to 20 Newton and D, which is distance, is equal to 2 meter. So we multiply 20 by 2 and we get the answer, which is 40 joule. So as we see in the second problems, a force of 50 Newton is applied parallel to the gradient to move a 5 kg block up a 30-degree incline. The kinetic friction coefficient between the block and the incline is 25 in moving the block a distance of 10 meters. So, how much work does the 50 Newton force do? Over the same distance, how much work has been done on the block? So, this is the solution. It is easy to figure out how much work does the 50 Newton force has done. The work has done is simply W equal to F multiplied by D. So, we get the answer, which is we multiply 15 by the 10. So, it is equal to 500 joule because it is applied by parallel to the gradient. So next, finding the total amount of work completed on the block is more difficult. The first step is to determine the block net force, which is in order to accomplish the question, we create a free body diagram as shown as the figure in the screen. The block receives a force down the gradient of magnitude, which is mg sin 30. So after that, we multiply the number 5 by 9.8 and by 5. So it is equal to 24.5 Newton due to its weight, which is mg. And in addition, a frictional force opposes the motion, causing the inclination to descend. So after we apply the formula in the answer, we got the 10.6 Newton as given its magnitude. So furthermore, the normal force and the perpendicular to the inclined component of the gravitational force cancel out perfectly. So as a result, the net force acting on the block is 15 Newton minus by 24.5 Newton minus by 10.6 Newton, that is equal to 14.9 Newton that directed upwards. So, the block is subjected to a net work by this net force. As a result, the answer is 149 is the amount of work that done on the block. So, in conclusion, a two-dimensional vector has two components, for example, an impact in two different directions. Methods of vector resolution also can be used to determine the quantity of effect in a given direction. So, to investigate these concepts, we ought to less time to generate a few fundamental physics laws and operators that, while simplistic, they have a compelling properties. As an example, in the physics field, teachers in school play an important role in explaining the use of vectors in daily life. So in this context, physics and mathematics teachers must work together to help their students to understand on how vectors and physics are intertwined and used in our daily work problems. We have to teach the students so that they will understand that vectors and physics are not only used to learn in their textbooks for their examination, but are also used and applied in their daily life.
So, how is my video?
From my opinion, your video is very interesting. Your explanation about the use of vectors in physics are very clear. I can understand and interested to what are you presented. So far, I think this is the good presentation and the editing is so nice. This is so good overall.